Hi everyone, my presentation today is on direct air capture. Direct air capture is a technology that uses large-scale fan facilities to remove large quantities of carbon dioxide from the air. The carbon dioxide removed from the air can be stored on the ground or reused for other purposes. Some of the purposes for carbon dioxide removed from the air are the enhancement of oil recovery by injecting it into oil fields. Sources claim that this process is both a storage and recovery method. Shown here is a model of the Stratus plant in Texas, one of the largest projects in the USA to date. There are other larger plants across the world, but Stratus is the largest in our country. 1PointFive, the engineering company behind this project, said that the facility would be commercially operable by mid-2025. However, my research did not yield any information that the plant is actually open as of July 2025. Other sources said, however, that the overall completion is estimated between 94 and 98% of the work done. Direct air capture is one of the many methods being studied, and amongst the few being deployed. I chose this method specifically because, although expensive, is one of the methods that are actually in progress. Texas, for instance, is one of the main producers of carbon dioxide in our country, then California. Concerning pollution rates are like a sand clog against the health of our planet within the next 10 to 50 years. There are two environmental concerns regarding direct air capture as a solution. First, it appears as a detraction from the actual problem. And two, carbon dioxide pipelines are a frightening risk. Considering that these plants have been deployed successfully around the world since 2017, when Climeworks opened a facility in Switzerland. Climeworks is the same company to have built the facility shown here, located in Iceland. It is safe to say that technically speaking, this is a feasible solution. It is expensive, but governmental and environmental agencies are supporting it with incentive programs. According to the State of Carbon Dioxide Removal report, it estimates that 7 billion to 9 billion metric tons of CO2 must be removed each year by 2050 to meet the Paris Agreement. Yet, direct carbon capture facilities account for a very small fraction of this goal, already demonstrating that it is not even close to meeting this goal. This method is also less successful than natural methods such as tree planting. Aside from its large-scale planning, this method is also very costly. Some companies claim that over time the price will be reduced, especially as the carbon dioxide stored can be sold and repurposed. Governments are also mostly supportive of this solution and have gone behind the funding of certain projects, such as the Biden administration. Here we can see an oil terminal in Scotland that is using captured carbon dioxide to squeeze fossil fuels from already depleted wells. In my opinion, this validates the concern of those who claim that direct air capture is a distraction that will allow the continued exacerbated extraction of natural resources. In other words, this is a loop solution that is selling the idea of helping climate change, but has closed door agreements with the oil industry. Not to mention, the temporary or permanent storage of large amounts of carbon dioxide is very concerning and sounds like a disaster bound to happen. One last point to touch on here is the powering of these plants. Many plants are using solar energy or geothermal energy, such as in Iceland. Some experts argue that the amount of energy used to power a DAC plant should be best avoided altogether to reduce the amount of energy consumed. This brings me to the risk management strategy I want to close this with. Location is very important when planning, but energy planning is crucial for the actual success of these plants because their success cannot be measured simply by the amount of carbon dioxide they absorb if we don't take into account the amount of energy it takes to power. Transparency is always a risk management strategy, not always followed. In my opinion, the most important concern that this geoengineering technology is a practical solution that does not cause other problems. Conclusion. So finally, I would like to say that of all the options studied in this module, planting more trees, cutting less, reducing carbon producing products should be the first and most important tool. My conclusion is that all of these studies are inarguably fascinating. It is undeniable that we have a consumption problem, and no method is going to solve that unless we take a universal approach to prioritize the well-being of our planet, starting from the top, not from the bottom, as we're conditioned to operate when it comes to sacrifices.